Hello, we are Group 7, and we consist of myself, Darren, Dana, Delaney, Kat, and Hannah, and we're going to be explaining a portable water purification design through mass transfer analysis. More than half of U.S. consumers are concerned about contaminants in their drinking water. To help with this, most U.S. consumers drink filtered tap water from Brita products and other filtration systems. But these products can be expensive and are not built for travel, so we've been designing a product to help fix this problem. Activated carbon is what is used for filtration in Brita products and other filters. It works as a filter, absorbing large particles suspended in water. So our design is a single-use, portable water purification system using activated carbon gravel in a tea bag design, which makes this design low-cost and portable. Next, we can test this design by analyzing to see if the activated carbon tea bag can effectively perform mass transfer in a reasonable amount of time. If it does, then this design would hold true to be an effective way for the public to purify their water. To prove this analysis, we decided to run trials with food dye acting as a contaminant in water. We observed if activated carbon could remove food dye by analyzing the color change of the solution over time. For each trial, we put the tea bag filled with activated carbon into the base solution of food dye and water and observed if there was any color change after some time. The trials used different concentrations of food dye and water and different amounts of activated carbon gravel for the trials, as well as varying treatments to the carbon prior to the trials, such as rinsing or cleaning. At the end of each trial, if a color change occurred, that would represent that the activated carbon performed mass transfer and purified the water, thus proving our hypothesis. A concentration gradient defining concentration over time had also been created to further prove our hypothesis of there being less concentration at the end of the experiment than the beginning. In the first trial, we had the base solution contain 4 drops of green food dye per 524 milliliters of water and 3 tablespoons of activated carbon gravel in a single tea bag. After we ran the experiment for around 20 minutes, we saw no change in color, meaning that the solution was too concentrated or too little activated carbon was used. Then, our second trial had 1 drop of green food dye per 500 milliliters of water and 4 tablespoons of activated carbon in 1 tea bag. But this trial turned the solution gray after about 5 minutes due to the carbon powder leaking through the tea bag and changing the color of the base solution to gray. We then ran the same concentration and activated carbon values from our second trial, but we had triple bagged the activated carbon to create a finer filter. So this time, the activated carbon was in 3 tea bags total. However, after some time, the base solution turned gray again. For the fourth trial, we had used the same setup again from the previous 2 trials, but this time we had rinsed the activated carbon before we triple bagged it again. This ensured that the base solution would not turn gray from the powder leakage of the activated carbon. However, after some time, there was no change in color observed due to too much volume and too much mass to remove for the activated carbon to perform any mass transfer. Then, after fixing all of our previous problems in previous trials, our final design setup ran as such. We had placed 4 tablespoons of activated carbon, which resulted in 14.5 grams, in 1 tea bag, then rinsed that tea bag with water to ensure that it would not make the solution gray. Then, we double bagged the rinsed activated carbon tea bag, resulting in 3 tea bags total. Next, we had 1 drop of green food dye per 500 milliliters of water. Then, to fix the problem of having too much mass to remove for the activated carbon to perform any mass transfer, we only used 100 milliliters of the solution for this experiment. So now that we have our setup complete, we started our experiment by placing the triple bagged rinsed activated carbon into the solution at room temperature. We would run the experiment for a total of 40 minutes, and as you can see, during the experiment we would raise the tea bag to show the full solution in its color every 2 minutes to collect 20 data points in total. During the experiment, we were looking for any signs of mass transfer, which included color change representing less concentration of contaminant in the water. At the end, we can see that the overall solution did become much clearer, meaning mass transfer did occur. By analyzing the data points collected during the experiment, a concentration gradient was created. This gradient further demonstrates that mass transfer occurred as it defines that the concentration decreased over time. This decrease in concentration means that the driving force behind the mass transfer was the activated carbon absorbing the dye from the water. Also, we found a value for the total mass flux by using Fick's law of diffusion and other calculations shown that further proved that mass transfer occurred. In conclusion, the activated carbon does provide a way to demonstrate mass transfer and purify your water on the go, but it takes an unreasonable amount of time for the contaminants to filter out. Also during the trials, we found that the carbon powder had leaked through the tea bags, which is just unsanitary for consumer use. Therefore, this solution may not be a reasonable design to use for quick portable water purification. Thanks for watching!